Assalamu alaikum everyone. Today I'm going to present my FYP. So my FYP title is Estimating the State of Charge of a Nickel Cadmium Battery by System Identification and Neural Network Models. But let me introduce myself first. My name is Muhammad Morsi. My matric number is 195077 and my supervisor is Prof. Dr. Muhammad Khair bin Hassan. So the presentation outlines for today is going to be introduction, problem statement and literature review, methodology and objectives, results, and finally conclusion and some recommendation. So for the introduction, we are going to talk about the nickel cadmium and why it's important and what's the advantages of nickel cadmium batteries. First of all, it's a rugged and high cycle count with proper maintenance. Only battery that can be ultra fast charged with a little stress, and good load performance, forgiving if abused, long shelf life, can be stored in discharge state and needs priming before use, simple storage and transportation, not subject to regularity control, good low temperature performance, economically priced. Nickel cadmium is the lowest in terms of the cost per cycle, and not forget is the number one battery for electrical vehicle. So the problem statement that we have is the nickel cadmium batteries have a problem. There are some uncertainty with the battery behavior, which can lead to unstable performance and this promising power source to be unreliable. There is an example is memory effect, which if there are continuous cycles of charging and discharging to the same level, the nickel cadmium acts as a dead battery. But we can overcome this problem by estimating the state of charge of the batteries to prevent such an event. And the state of charge is an important parameter which reflects the battery performance. If we have managed to get accurate estimation for the state of charge, it's not only going to protect the battery or prevent the over discharge, but also is going to allow the application to make rational control strategies to save energies. So these are the papers that I depend on making my project. First paper is the state of charge estimation for rechargeable batteries based on artificial neural network techniques. This method they are planning to the method was dependent on the artificial network techniques to estimate the state of charge, depending on the current and time input in the charging process only. The results they could create the models with ANFIS and artificial network and able to estimate the state of charge on current and time as input and the state of charge percentages as output. The second one is modeling for lithium-ion batteries A18560 based on system identification method. They use the discharging technique using constant current for 1 ampere to identify the mathematical or black box model for lithium-ion batteries. The results they could generate mathematical model that can estimate the state of charge lithium-ion battery by accuracy more than 95%. So after I show the literature review that I used, so I managed to reach to some objectives that we need to do, which is to create a mathematical model that can predict the state of charge of the battery with high accuracy to the whole process, whether it's a charging and discharging, not only in one mode. To create a neural network model that can estimate the state of charge with minimum error. So this will be the second model that I'm going to implement. And the third one is trying to apply those two models in the lab and check on different and try to apply these models with different battery size so we can check practical whether these two models are working correctly or not. So the methodology is first for collecting the data in the lab. We are going to start measuring initial battery voltage level and we will call this one V0. So if 0 equal to Vmax, it will discharge the battery until it reach to the V minimum, and once it's reached to V minimum it will stop, and if V0 is not equal to Vmax, it will always charge the battery until V0 equal to Vmax. So this is for collecting the data in the lab. This is the methodology. So the results in this chapter, we are going to show the data that we have obtained from the lab. So the first one is the discharge process, and I managed to create a graph. And for the second one is the charging process, as the voltage is the input and the capacity is the output. So after this, we are going to I'm going to import the input data as a voltage and output data as a capacity, and then I managed to generate the transfer function for the charging and discharging process, which it fit to estimation data by 99.2%. Then I pressed the quick start, so I could get the battery model accuracy based on measured and simulated output, and I could reach the model accuracy to 93.75, so almost is 94% of the accuracy. Next I began to work with the neural network. So first of all, I opened the neural network to neural time series, and then I chose the NARX, which is nonlinear autoregressive with external input, because this will generate much better data and much accuracy. Then I press next to validation and test data. I turned the validation and testing to 15% and 15%, and the training will automatically be 70%. Then in the left menu, I selected the data, and I make the inputs as VA, which is voltage and current, and the target data I choose the cap, which is capacity, and I imported them from the workspace in the MATLAB. Then I press next, and I trained the data, which it gave me the results on the right photo. The results for training, validation, and testing, and most of them, they are promising. The mean square error is really near to 0, which means the error is so small, and the regression R values are really near to 1, which it has a relationship between the inputs and the outputs. These are the neural network progress details, as you can see, and the histogram graph, it shows that most of the samples are near to the 0 error with validating, testing, and training. So it nears to 0.0018, which is a very good result, that the error is so small. Regression graph, as you can see, most of the data can really fit on the graph, and the error is so small also. And the training performance, it tells us like which exact epoch that it has the best results, which in this case is the epoch number 13. After this, the NN tool system, it can generate Simulink diagram and also can generate virtual neural network, as you can see. So this also we can use it later, as we can make a different input in the future if we manage to go to the lab. So in conclusion, in this project, the mathematical model and the neural network model have been successfully implemented. Both models achieved estimating the state of charge of the battery with high accuracy, 99.2% for the transfer function and 94% for the battery model for the system identification, and almost 99.9% of accuracy in the neural network. These two models can be tested on different naked batteries with different sizes to check them practically. But unfortunately, for the situation of COVID-19 lockdown and the incapability of going to the labs, the last object cannot be done, as I can't go to the lab without a permission, and the permission actually right now is not also valid. So the recommendation is trying to test these models in the lab on different naked batteries with different sizes, and try to endorse the time as input, as this will give much more accuracy to the models. So that's all from me. Thank you so much.